Okay, let us today discuss about the mean value theorem of the differential calculus. Okay, this theorem says if a function f is continuous on the cluster interval AB and differentiable on the upper interval AB, then there exists a number c in the upper interval AB such that f prime of c, or the derivative of the function at c, is equal to f of b minus f of a over b minus a. Below is the geometric interpretation of the mean value theorem. Okay, the f of a in this case is this height. This height is the f of a, and the f of b is this height, and the difference is the difference between the y coordinates, and the difference between b and a is the difference between the x coordinates. So we know that the difference between y coordinates and the x coordinate is the slope of the line passing through a and b. In this case, the below the secant line. Okay, and the mean value theorem guarantees or says there exists a tangent line that is parallel to this secant line, that is this above line, this line. Okay, and passing through this point as C. Okay, this is C, guaranteed by the mean value theorem. Okay, let us explore this mean value theorem by using an example below. So here given f of x is 5 minus 4 over x, and find all values of c in the upper interval 1, 4 such that the derivative of the function at c, or f prime of c, is equal to f of 4 minus f of 1 over 4 minus 1. In here, a is equal to 1 and b is equal to 4. Our open interval is 1, 4. Okay, first we need to check whether this function satisfies the conditions of the mean value theorem. That is, it should be continuous over the interval, cluster interval 1, 4, and it should be differentiable over the upper interval 1, 4. So this function 5 minus 4 over x is continuous over the interval 1, 4 and is also differentiable. There is no discontinuity over 1, 4. Okay, the only discontinuity for the function is x is equal to 0. Okay, so 1, 4, 0 is not inside of the interval 1, 4. So the conditions of the mean value theorem is satisfied. Okay, now let us explore the values of the c. So here, f of b minus f of a over b minus a is equal to f of b is equal to, okay, let me calculate f of b. F of 4 is equal to 5 minus 4 over 4. That's equal to minus 1. It's a 4. And f of b is, sorry, f of a is f of 1. That's equal to 5 minus 4 over 1. That's equal to 1. So f of b minus f of a, f of b is 4 minus f of a is 1 over b minus a, that is 4 minus 1. That's equal to 1. Okay, now we need to equate these 1 with the f prime of c. So what is f prime of c? So let's calculate the derivative of the function. F of x is equal to 5 minus 4 over x. F prime of x is equal to 0 minus 4 over x to the negative 2. So that becomes x squared here and then negative here. So that's equal to 4 over x squared. Okay. So f prime of c is equal to 4 over c squared. And we need to equate this with this one, 1. So 4 over c squared is equal to 1 implies c squared is equal to 4. So c, sorry. So c is either plus 2 or minus 2. So we need only the positive solution because negative 2 is not in the interval 1, 4. So accept c is equal to 2. That means that there exists one tangent line parallel to the curve or secant line at its x is equal to 2 or c is equal to 2. Okay, thank you.